Good afternoon, everybody. We're going to start the Asia 6G Research Initiative Open Workshop and MOU ceremony between KICS and SUTD in 5 minutes. So we're going to just already past the 5 minutes, and then we're going to start right now. Okay, my name is Jaehyun Kim, and currently professor in Aju University and Vice President KICS. Let's start the Asian MOU ceremony between KICS and SUTD. Before the Asia, the 6G Research Initiative Open Workshop. I'd like to take a moment to introduce the attendee for this MOU. For the Korean side, KICS, here is Professor Yohan Shin, President of KICS here, and then Professor In-gi Hong, Executive Vice President and Chair of the 6G Research Initiative at KICS. Also, the Professor Byung-hyo Shim, Executive Director of 6GRI KICS, attended. From the Singapore side, as Singapore University of Technology and Design, Professor Tony Kwek, Director, Future Communication Research and Development Program, he is here. Okay, first, the welcome address will be given by the president of the KICS, the Professor Yohan Shin, and let's welcome the President Shin of KICS.
Good afternoon. This is Professor Yohan Shin, the president of KICS. On behalf of the KICS, I'd like to express my sincere and warm welcome to everyone attending the first Asia 6G Research Initiative Open Workshop and KICS Singapore University of Technology and Design, SUTD, MOU ceremony here at the beautiful city of Seoul and online. For over the past 48 years, KICS has served as the top accredited organization for Korea's information and communications, and currently has more than 28,000 active members. Activities of KICS include advanced research, journal publications, organization of conferences, development of new academic platforms, and international academic collaboration with Singapore, Japan, China, UK, and North America, to name a few. We believe that collaboration between Singapore and South Korea's academic and research institute in the area of 5G and 6G is very important and beneficial to both countries. On this consensus, the KICS has signed an MOU with the Future Communications Research and Development Program of SUTD on Beyond 5G and 6G on January 1st, 2022. And we'll have an MOU ceremony today to strengthen cooperation and to discover ways of collaboration between the researchers for sharing ideas and conducting joint research beyond 5G and 6G. Building up on the KICS SUTD activities, this year the first Asia 6G Research Initiative Open Workshop is proudly held at KICS building in Seoul. We hope this workshop will contribute by increasing collaboration and exchange of 5G and 6G technologies, and serve as a platform for creativity and innovation for all of the world. I'd like to thank all the members of KICS 6G Research Initiative and our valuable speakers for the excellent preparation. And especially I thank SUTD for collaborating this workshop. I also would like to take this opportunity to especially thank Professor Tony Kwek, Professor Jong To Chung, President of SUTD, President Byung-hyo Shim, and President In-gi Hong for their tremendous effort and this dedication to this workshop and MOU ceremony. Thank you again for attending the Asia 6G Research Initiative Open Workshop and the MOU ceremony. And I wish you all a wonderful time. Thank you very much.
Thank you, Professor Shin and President of the KICS. And then next to also the welcome address and introduction of 6GRI will be given by the Professor In-gi Hong. He is the Executive Vice President and Chair of 6G Research Initiative of KICS. Let's welcome Professor Hong of KICS.
Thank you for joining 6G R&D Corporation MOU ceremony. So I prepared the short address. However, the President Yuan Shin already covered all of my address. So everything is almost same. So I'd like to skip my address and the just I hope that this MOU will promote the R&D in both countries, and we hope to expand the close relationship to the other country. Today, we invited Japan, Taiwan, and we want to extend our collaboration between the countries. So we try to make the multilateral MOU in later. Okay, thank you.
Thank you again, the Vice President, and appreciate for the very short welcome address. Okay, then now the next is I would like to state the agreement between KICS and SUTD. It's actually 2 pages MOU, but I'm going to read a little bit about that. The last part is very similar to the other MOU statements. Okay. This memorandum of understanding is entered into on 1st January 2022 by and between KICS, the representative institution on ICT authorized in Ministry of Science and ICT of Republic of Korea, and Singapore University of Technology and Design, a company incorporated in the Republic of Singapore and having its registered office at the 8 Somafa Road, Singapore. SUTD has been appointed by the Infocom Media Development Authority of Singapore to be the host institution for the Future Communication Research and Development Program. The FCP was established under the Communication and Connectivity Research and Development Fund funding initiative and supported under the Service and Digital Economy domain of National Research Foundation's research, Innovation and Enterprise 2020 plan, which will run from 2021 to the 2025. And then the other one is we have many statements, but most of this MOU statement is very similar to others. So I'm going to skip all to reach the time. I'm going to skip all the statement. Okay. Okay. Also, the next one is a signing ceremony. But excuse me. But already the signing was have done in this year, earlier of this year by online. So I would like to ask the president and the director to come over here and exchange the signed agreement. Would you forward and then exchange the agreement? 그러시죠? 네. 앉아서 사인 한번 드릴까요? 이것을 서로 어떻게 하는 거죠? 두 분이 약속을 써야 돼. 하나씩 들고 올라갈까? 올라가. 딱 좋네.
하나, 둘, 셋. 한 번 더 찍을게요. 하나, 둘, 하나,
Okay, thank you very much.
Altogether. 저 세부터 먼저 칠 때 세 명이 먼저 따는 거.
자, 하나, 둘, 셋. 한 번 더 찍겠습니다. 하나, 둘, 셋.
다 같이 저희가 이렇게 하고 싶죠? 네, 네. 이거 알았어요?
네. 저 좋은 것 같아요. 네, 찍겠습니다. 하나, 둘, 셋.
지금 살짝 좀 찌그러져가지고요. 한쪽만 좀 찌그러져 보는 것 같아요. 이상하게 보이니까.
한 번 더 찍겠습니다. 김재현 씨 조금만 더 오는. 조금만 더 오는. 네. 네, 좋아요. 네, 한 번 더 찍겠습니다. 하나, 둘, 셋. 네.
네, This is the end of our ceremony, but Yeah, actually, next.
Thank you for coming, right?
Take picture, take picture. Okay, this is the end of the ceremony, and then we're gonna move on. The next one is Asia 6G Research Initiative Workshop. So we have a 2-minute break, and then we're gonna start later.
Everyone, my name is Won Shin. I'm session chair of this session. I'm an associate professor at Asia University, Korea. So today we're going to have 5 presenters in this workshop. For the first session, we will have 3 presenters for the next 1.5 hours. So, first presenter is Mr. Takashi Nakamura, Institute of Commercial Japan. So if you're ready, you can start your presentation for the next 30 minutes. Mr. Nakamura?
Yep.
Floor is yours.
Okay, yeah, thank you very much for your introduction. Actually, my name is Takehiro Nakamura. That's a long in your maybe explanation. Yeah, actually, in any case, thank you very much for inviting me to this session, great session in ICC, and it's a great honor to provide my presentation. Actually, I'm working for NTT Docomo, but I have another hat. I'm a chair of the white paper subcommittee of Beyond 5G Promotion Consortium in Japan. So I'd like to explain our white paper contents of the white paper contents of the Beyond 5G Promotion Consortium. Okay, I will share my screen. Can you see my screen? Should be okay? I hope it's okay. Okay. So anyway, I'd like to explain the white paper contents of the Beyond 5G Promotion Consortium. And please note that the following slides are abstract of the output of the Beyond 5G Promotion Consortium that has already published on the web page of the consortium. And first of all, I'd like to explain the promotion consortium, and that has established in the end of the 2020, and consortium has 2 committees: the committees for planning and strategy and the international committee. And under the committee for planning and strategy, we have a subcommittee of the white paper development, and I'm a chair of the white paper subcommittee. And white paper subcommittee, the objective of the subcommittee is a strong and lively society expected in the 2030s and clarify use case and the requirements of the Beyond 5G, and take international leadership by developing concept of Beyond 5G early on and reflecting it to international standardization, including ITU, and contribute to the strengthening international competitiveness by capturing and reflecting views from various industries and developing meaningful concept of beyond 5G for all industries. And we have actually 3 groups under the subcommittee. First one, the Vision Working Group. This is developing the vision of the white paper. Second one, Technology Working Group. This is this working group developing the technology parts. And the third one is WP5D ad hoc. And the output of our subcommittee white paper content should be provided to the WP5D activities. So this ad hoc treating the contributions to the WP5D. And this is the structure of the white paper. And yeah, especially important parts should be, for example, yes, chapter 4, trend from other industries. And from the beginning, we think that it is very important to capture the requirements, views in the 2030s, 6G era. So we had many workshops, inviting the variety of the industry key persons, and their opinions are captured in white paper in this chapter, chapter 4. And also chapter 5, capabilities and the KPIs required in Beyond 5G. This part should be, of course, very important to clarify the KPI and the requirements for the Beyond 5G 6G. And that can be proposed to the ITU WP5D. And the chapter 6, technology trend. And I know that many projects treating the variety of the technologies for the 6G. And in our subcommittee, we also study the technology trends. What kind of technology need to be applied to the 6G beyond 5G? That's studied and captured in the white paper. I will explain one by one, roughly. First, the beyond 5G use case and the requirement. This is provided by the Vision Working Group. Actually, we had many workshops as listed, as you can see on this slide. And as you can see, the variety of the industry people provided their presentation. That was so informative to study and to forecast what kind of the application services will be needed in each industry, and what kind of the performance should be achieved for those kind of the use cases for each industry. That has studied and captured in the white paper based on the workshop discussion results. And this is a detailed table of contents on the vision-related topics, especially in the chapter 4, trend from other industries. As you can see, there are many sub-chapters that they are corresponding to the industries: finance, construction, real estate, logistics, transportation, telecommunications, media, blah, blah, blah. So many industries. And yeah, of course, some of them are well discussed and studied, and the big contents are captured in the white paper. But some of them are not so studied very well, and the contents are rather small. So for the future, in the next version of the white paper, we will add more contents according to the further study. But in any case, some of them are well discussed, especially on the healthcare related aspect or big automotive aspect. Yes, I will explain some of them. And yeah, for example, this is automotive. And first of all, of course, it is important to identify what is the issues for the 2030s 6G era in the automotive industries. And we identified that, as you can see on the head of this slide, the aging society restricts people's mobility in rural areas, and the population areas causes traffic congestion. A future society is envisioned in which all people can be ensured with unconstrained and efficient mobility irrespective of their living areas. As you may know that we have a very serious social issues in terms of the aging population in Japan, and big cultural differences between the rural area and the urban area. So mobility, especially mobility in the rural area, is a very, very serious issue. So automotive mobility should solve those kind of issues for the future. And we identified issues analysis and the key tasks, and also future vision. And on this slide, the whole kind of future vision listed. You can see the society, all people can move freely and efficiently. Second, mass platform allowing the multimodal mobility of people. And three, collaboration between vehicles with smart cities. And four, enabling digital society to realize mobility inclusive. So based on these studies, we tried to identify what kind of requirement we need to identify for the automotive industry. And this is our studies. And according to the studies toward the automotive society in 2030 era, beyond 5G shall require the integration of highly accurate sensing and the communication, distributed AI learning, and the inference and ultra reliability. And requirements are shown in the bottom of this slide. And two aspects: safety driving assistance, left-hand side, and the right-hand side is automated driving. And each topics we tried to analyze at what kind of the requirements, two-dimensional requirements need to be identified. And each graph, horizontal line shows the requirement on beyond 5G. And vertical line, for example, left-hand side, the vertical line of the left-hand side, improve driving pressure. And red square show the really high requirements in terms of both of the beyond 5G and also safety driving assistance point of view. A real future automotive image, yes. And especially beyond 5G era, red square part, complement V2I cooperation by sensing. And yes, sensing should be very important for the future, and the enhanced connectivity and availability. Yes. And the right-hand side, this is an aspect of the automated driving. And similarly, horizontal line shows the requirement beyond 5G, and also vertical line shows the improved safety on automotive driving. And the real future, the red square parts, right-hand side, maybe we should provide the sensing and the distributed AI learning and the interference based on the sensing accuracy, the centimeter level, and the remote monitoring and the remote driving. In this case, data speed should be very high, and a very short latency will be required for the beyond 5G. So we studied this kind of points for the automotive industry. Next, the medical industries. And first, similar to the automotive industries, we studied the issues and challenges, tasks for the medical industries for the future. The current issues is listed. Three issues are listed here. Coexistence of the various people in a super aging society. As I explained, super aging, aging population is a very serious issue, and then from the medical industry point of view, that should be a very serious issues need to be addressed. And the new solutions to unknown diseases. Third one is the further development of medicine and the medical device. And bottom of this slide shows the expectation of the future life. And we listed, we showed 5 expectations. First one is the support and the reproduction of physical functions and abilities. Second, immediate response to unknown infectious diseases. Number 3, development of medical technologies. 4, support for super aging society. And 5, extension of healthy lifespan. This should be a very important expectation of the future life, we think. Based on these studies, we listed the requirements for the beyond 5G from the medical industry point of view. And we identified the major use cases, 5 use cases with the beyond 5G. As you can see, the left top. And the first one is assisting perceptual abilities, augmented human, brain machine, and so on. And the minimum contact monitoring infections. This is positioning, centralized management of the health status we needed. And number 3, database on the genome analysis. This should be a personalized medicine, AI-based drug discovery. Kind of use cases can be considered. And the telesurgery, robotics, AI-based surgery can be considered. And minimally invasive surgery. This means nano micro robotics and energy harvesting. This kind of very, very future excellent use cases are identified. And in order to realize these kind of use cases, we analyzed the beyond 5G requirement from the medical industry point of view. As you can see in the left bottom, the telesurgery, the tens of gigabps throughput, and also 10 to minus 7 reliability will be needed. And minimally invasive surgery case, up to tens of millions kilometers per kilometers connectivity, very wide coverage, and autonomous communication control of the devices. And these kind of the use cases and requirements are shown in the right-hand figure to facilitate the understanding. Yes, but in any case, the variety of the use cases can be considered for the medical industries, and very high requirement variety of the very high requirements would be needed in the 2030s, we think. This is a medical or industry study results. And actually, we studied many aspects for the variety of the industries, but the time is limited and I skipped. But if you have any interest, please visit our website and white papers. Okay, so from here, I'd like to explain the capabilities required in the beyond 5G. And based on the study results for the each industry requirements, we summarized the capabilities you can see on this slide. And for example, top, ultra fast and large capacity. Industry by industries, requirements are a little bit different, but for the 2030s, in any case, the very high data rate will be needed for the many of the industries, as you can see. And the ultra low latency, and this is a little bit different depending on the industries. Some industries need a very short latency, like 100 microsecond. This is for the local communications, motion control machinery case. But some others, maybe could be several milliseconds level can be allowed, and some cases more. So it fully depends on the industries for the latency aspects. And the time synchronization activities also required in some cases for very tight requirement to be needed for some use cases. And also ultra security resiliency and very high 10 to 6 or 10 to 7 level of the requirement to be needed. Positioning, sensing, and centimeter level sensing accuracy be needed. And also the numerous connectivity and the coverage, as you can see, the very high requirement be needed for the several industries. And these are the quantitative requirements. We can set some kind of the quantitative value for other requirements. But as you can see on the screen, there are some cases it is very difficult to identify the quantitative requirements. So in that case, we listed the qualitative requirement. For example, autonomy, ultra low power consumption. It's a little bit tricky to clarify the quantitative requirement, and we listed the qualitative requirement like this. And others, yes. So you can see NTN aspects, yeah, qualitative, yes. Okay. So based on these kind of studies that we try to address on the technical aspect, and these are the detailed of the table of contents on the technical study results. First, target key performance indicators. And in order to clarify the KPIs, it is needed to clarify the conditions of definition of each KPIs. And especially KPI by KPI, the definition could be different, I think. As you can see on the screen, maybe from where to where, which KPI we defined. And for example, application level requirements, of course, very wide application layer to application layer in the terminal side and the network side should be clarified. And also, for example, mobile system KPI, capacity, connection, density case. This is only the very short distance between the user equipment and the edge node in the network side. And the network system KPI, energy efficiency, sustainability case, maybe from the user equipment to the cloud environment, like range should be considered. So in any case, this kind of the clarification to define the KPI we needed to be seen. And based on this, we defined some of the KPIs. And according to the, based on the study result from the capabilities requirements from the each industries, we listed the target KPI quantitative requirement. And this is the most severe requirements according to the study result of the variety of the industry requirements. And from top, user experience data rate, downlink, uplink, and the big data rate, and so on. So in general, we should consider the 10 times or 100 times higher performance compared with the 5G requirement for the 6G beyond 5G. And more requirements need to be considered, especially on the bottom area coverage and aspects. And also, so these are the summary of our target KPI and the requirements for the 6C. And this is the qualitative requirements. Yes. No quantitative values, but in any case, these kind of the qualitative requirements also need to be shown in the white paper, white paper. Yep. Okay. Okay, so technology trend. And first, I'd like to say something on the spectrum bands. And it is, of course, very important to clarify which spectrum band could be the candidate for the 6G system. And it is premature to clarify that, and we need to study more and more. And we need to discuss with the regulators, and we need to have some kind of the harmonization discussion globally. But in any case, toward the 6C, many people have a strong interest in the very high spectrum band, like up to sub-terahertz. And left-hand side graph shows the frequency band versus bandwidth. And what kind of the bandwidth can be considered at the which spectrum band? In principle, at the higher spectrum band, we can use a much wider spectrum band width. And referring to the 3GPP defined spectrum bands, FR1 and FR2, maybe bandwidth and the frequency, center frequency ratio can be around 10% or less. So considering that, for the more than 50 gigahertz to the more than 100 gigahertz, we can consider the bandwidth of from the 4 gigahertz to 8 gigahertz bandwidth at very high spectrum band. Yes. So concerning that, we should try to identify the appropriate spectrum bands toward the 6C, and we need to negotiate with the regulators. But on the other hand, frequency assignment has already done so many for the variety of the industries. And the right-hand side figure shows the Japanese situation. And for the many industries, already spectrum has allocated even for the very high spectrum band, like EHF. Yeah, but maybe we can find some kind of candidates spectrum band at the very high spectrum band, up 100 gigahertz or higher, and we need to identify and we need to negotiate with the regulators. Yes. Okay, this is some kind of initial thought on the spectrum bands. And the spectrum propagations, radio propagation testing has already conducted by the variety of the many companies. And some of the results are also captured in our white paper. And this graph shows us one of the testing results. And left-hand side, this is some measurement results of the 3 kinds of the spectrum band, 2 gigahertz, 26 gigahertz, and 300 gigahertz band. Yes, each spectrum bands are testing result. Test results are shown in the dot in each color, red, blue, and green. And results show that, compared with the IQL path loss channel model, measurement results show that the path loss is a little bit smaller than the path loss model. We think that this is caused by the reflections, yes, of the building in the urban area. Yes, this result is an urban area result. So in any case, this kind of that measurement would be more test result would be needed to define the appropriate channel model for the 6C. Yeah. And next, technology trend, and we captured a variety of the technical technologies to be used for the 6C, and many variety of aspects, as you can see in the table of contents. Trustworthiness, network energy efficiency enhancement, and the network coverage extension, MTN scheme, network architecture, and also many technical components and proposals identified for the wireless and the optical point of view, as you can see. So this should be a big contents, and it's a little bit tricky to explain everything. And yes, in any case, this kind of the keyword is shown on these kind of slides, and I will skip the detail. And this is the wireless and the optical, many technologies identified already. Yes, like this. Okay, in any case, this is a very, very high-level explanation on the white paper. And I know that Korea and the other regions are also providing the white paper and very excellent study. And I'm very happy to exchange the information, opinions, study results to the Beyond 5G 6C after this. Yeah, thank you very much for your attention.
Thank you, Akihiro Nakamura. Also, sorry for the typo in your name. Thank you for your nice talk and sharing your story of how to promote Beyond 5G in Japan. So we are a little bit behind schedule, so we're gonna move to the next speaker.
Thank you.
Thank you. And the next speaker is from Professor Zhong Lin Wu from SNU. So the talk title is Toward Performance Guarantee Networking for 6G.
Hello, everyone. I'm really happy to have a chance to make a presentation on this 6G networking vision, especially on performance guaranteed networking. So unlike other presentations which are representing the national, the research, this is not some conclusive direction of Korea, but I believe by sharing this vision with Asia Pacific region, I think we can put together a great effort to make this really enabled to make some differentiation over 5G. Okay, my talk starts from this figure. As you can see, there are a lot of figures looking like this out there, and they are trying to compare the KPIs of 5G and 6G. And in the Samsung white paper, they claim to achieve like energy efficiency twice of 5G and the peak data rate of up to 1 terabps in some cases, right? And the air latency of 0.1 millisecond. Actually, these numbers are attractive, but what's the point of achieving these KPI numbers, right? And in reality, you cannot provide these KPIs altogether to a user, right? So each of the KPI may be achieved in some specific situation, but they cannot be achieved at the same time. And my question is, what is going to happen to the applications when these are achieved, right? And will these KPIs differentiate 6G from 5G? And unfortunately, my answer is no. And there is something very interesting about the 6G networking services. I just learned that fact from this figure I have used for many years. In this figure, you can see there are a lot of the cellular network-based services which require high bandwidth and low latency. And this gray area is showing that the new types of applications, especially for 6G, will be enabled by achieving high bandwidth and low latency together. However, these applications would not come immediately for 6G. And there is a reason. I just realized that when you just plot these performance figures of 3G to 5G and 6G, you will see the position of 3G, 4G, 5G, and 6G is about there. So based on this figure, you should be able to provide these new services to the users. However, there is something shocking, that is the residential internet speed of the world, including Korea, which is providing almost the fastest the performance to the household, is located there. Residential internet performance is slightly better than 5G, but it is, of course, lower than 6G expected performance, right? This means that up to 5G, we were able to borrow those services and applications which were developed for residential internet But from 6G, we have to develop our own applications and services, and there is no place to borrow those prepared services, right? So 6G with MEC will soon surpass the performance of this residential internet, and new services will not be ready when we try to launch 6G, because there is no other place where these applications can perform well, right? So some may say new services will spontaneously emerge when we prepare the 6G infrastructure. However, the waiting for the service developers to create such services after 6G is being deployed takes too much time, and this is simply our customers don't have or wouldn't allow. So we should nurture services by ourselves rather than waiting for their emergence, right? And how to create those services from the 6G performance perspective, well, we have to think very carefully what should be met in the 6G to nurture those services. And there is one interesting secret that Apple is doing to create their own ecosystem, that is to launch a new hardware and the feature with the software APIs, which is given to the application developers way earlier than their actual launch of the hardware. So as you can see here in the FaceTime, the Face ID interface, which was launched in the Apple keynote, they already hired one credit card company like Visa and provided that API, and they together created this service and launched the software and hardware at the same time. And we haven't done that until 5G. So I can tell you that there must be a way to provide the 6G APIs, which is not just socket programming API, which is simply which don't do anything for providing very nice performance guarantee to applications. We have to provide the 6G APIs with some grand vision and let those the service developers spend enough time to create such nice the futuristic services. So what should be the networking vision for 6G by having this whole story understood? Yeah, we are now talking about just improving the throughput and latency and the density of the network. So 6G is destined to lead the internet, right? Because this is even faster than the current internet and the network services therein. So I propose to enable this performance guaranteed type of 6G to provide this hyper-connected services. What I mean by hyper-connected is here the hyper means beyond. So this must be providing something beyond just the connectivity, right? Something beyond just the connectivity means there must be a expectation of the service providers and the customers that this service will be fluently provided even when I'm moving, even when I'm on an airplane, or even when I'm on sea, something like that, right? So 6G is talking about expanding its service area, but providing such services fluently to those areas is a completely different matter. So when we say hyperconnectivity, we have to mean something, and I believe this hyperconnectivity in 6G should be fluently providing the service quality, whatever the situation the customer is in. So throughput and latency, we can tackle those numbers, but we have to design a different metric to make these applications to enjoy this infrastructure. Okay, so my proposed metric is object response time. So when you have data to process, for example, augmented reality, then you're going to sense something with your AR glass or whatever the device you have, and you will try to compute with that sense data and will try to provide the result to the customer. And you can do it over the network, right? So the response time from the moment of sensing something to the moment of providing the service becomes very important in the next generation services, because metaverse or the augmented reality, the virtual reality, or the telepresence, or the autonomous vehicle driving controls, all those new services will depend much more on this response time. And what I mean by object here is the application object. This is nothing close to just a packet or the physical layer frame. So as you can see in that figure, application is pushing its application object to the kernel through the socket. And actually, they don't know when this application object will be delivered to the other side, because the physical layer is only delivering these physical layer frames without knowing what's the boundary between these application objects. However, if you just think about the augmented reality case, whatever you sense should be delivered and should be processed, maybe with the neural network, and you should get the response. So this is one package of transmission to process or to make some progress in your application. So that's the set of data to be processed, delivered all together. So application object, or in 3GPP, from release 18, they call this in a different name, maybe application data unit. So whatever you call, this must be the unit to be handled, delivered, processed, all at the same time. So the object response time is given by this simple equation that is first bit latency plus transmission time. So the first bit latency is what we know from air latency and the wired network latency, and maybe the queuing delay and the computing time. So the first bit latency includes all these signal propagation related delay. And the transmission time is about the volume divided by the data rate. So if the data size is large, this transmission time is not going to be negligible, right? And the transmission time, to make it bounded, you have to keep your bandwidth very stable, even though when you move. So the first bit latency plus transmission time guarantee will make this application performance quite stable. However, there is one big concern, that is, as you can see, the application object size will vary over time. That means your performance guarantee should be made very adaptively to each of the object that application is creating. So the current scheduler that we use in 5G, like proportional fair scheduler or any other priority-based scheduler, has nothing to do with this application object, and they don't know the boundary of this object. So even though they try really hard to make the air latency or the throughput guaranteed, in terms of this application's point of view, you will see huge fluctuation in the service quality. So there must be a different approach to guarantee this. So once you can guarantee that application object latency, then you will be able to enable various applications and services nearly immediately. For example, remote surgery or the autonomous vehicles, remote processing for the collision avoidance, or the augmented reality services. Whatever you create in the local side, you can deliver that and get the processing within some time budget based on this guaranteed object response time, including this uplink, downlink, or the round trip cases. Actually, that is what we need to pursue in 6G. And you can create some API indeed from this idea. When I have an AL glass, I may capture some image with my glass, and I will take some frame. And this frame is typically encoded as a JPEG or the PNG or other lossy codec. and will be delivered over the network. Maybe we will ask them to process, but instead of doing that naive operations, what we can do is you use this response time guarantee API and encode this frame with the size that this network can handle, meaning that the cell network, like 6G, should be able to report this application that I can deliver this much of the data within your performance requirement. For example, my application wants to deliver all the objects within 10 milliseconds, then this network will say, to achieve the 10 millisecond with your mobility in consideration, I will tell you that your object size should be always less than 5 megabyte or 3 megabyte, right? If the situation is getting better, you can get the information like 100 megabyte will be accepted. Then you are going to use this API to deliver each of the application object and will get the response on time. Of course, to enable this, the network should be much more active and they should be able to control their radio resources much more intelligently. To do that, you need to put high performance of computing in the maybe LU level or the ORAN's LIC level, and it will increase the cost a lot of this base station and the cell network equipment. However, as we have created this API, which can actually request the service providers to pay for each of the use, we can earn actually more money. So this is a new ecosystem. So we get more money from this application provider and then invest that money to have our infrastructure ready for providing such services. So you can just think about the cloud computing services as of now, like Amazon cloud computing service. They are charging a lot of money for using extra number of GPUs, right? But in the cell network, we haven't charged for that at all. Here, when you are creating huge size of application object with the target application latency of like 10 milliseconds, then you should charge more. And if the situation gets even more difficult, for example, the user is moving fast, you have to charge more, right? So this is going to make this pricing scheme completely renovated, and then we can have more revenue to invest more on the infrastructure. Okay. Due to the time, I'm going to speed up. When I say this, some people who are working on computing area is always questioning this. You are talking about processing the data over the network, but the computing power is increasing fast. So why do we need the networking? And as a networking guy or the communication guy, I had to give the answer, and I prepared this slide. As you can see, the performance actually comes from the power. So when you use a CPU of 65 watts, you can actually do as much as that power consumption. If you use 300 watt power, the CPU, then you can have like about 5 times of the speed. So as time goes by, according to this Moore's law, you will scale up the performance, but actually you are spending more of the power in the computing. But in the case of this mobile platform, right, and the AL glass, where there is no battery space, there is no battery space to put, right? And the limited thermal management solution within this zero device platform, you have to keep your performance within some wattage, and we are focusing on performance per watt from now. Then in this graph, which is showing the trend of performance improvement over time with Apple's processor and AMD's processor, Intel's processor, if you focus on this 5 watt, which is typical in the smartphone device, the improvement over year is only 10%. Actually, the semiconductor revolution is not that much fast, given this size limitation or the power consumption limitation and the thermal limitation. So whatever we want to provide with our customers by the time of 2030, about the time of 6G is going to come, these semiconductor technologies would not be ready to create AL glass, which is performing really well without the help of networking, right? So there must be a secondary question to be answered in this the logic logical statement, that is, can we guarantee the response time over 6G with limited power with the help of this communication technology? And I will say, yes, we can. We have like 3 weapons. The first weapon is, of course, using more antenna and using the beamforming technology. So as we all know, originally the MIMO has been developed as a green communication technology. So to give the power focus more on a specific area, they use multiple antennas and created this beam narrow. So you can actually reduce the power consumption of this communication. And by shifting to upper radio band, you can also use the same power consumption, but with higher data rate. And there is one more secret weapon, that is densify the infrastructure deployment. So deploying like a base station, like the one thing in 10 meter or the 20 meters, you may say, oh, that's crazy. That's too much of the investment cost. However, to provide such a radical, futuristic application experience to user through 6G, there is no other way, I believe. We have to invest as much as this, and we have to think about how to earn that much money from this providing new services to the users. I'm not saying we have to get the money from the users. We have to get the money. I'm saying we have to get the money from the service providers. The users will pay almost the same fee, but the service providers should pay that much of the money to provide their services in a guaranteed way. Okay, one thing I want to show you is the PlayStation 5, the game engine, the graphic quality. This is so incredible as of 2020, like 2 years ago. And you cannot distinguish whether this is the pre-rendered one or the real-time rendered one, but actually this is real-time rendered one. It's pretty close to, yeah, the realistic, the movie. And as you can see, the billions of triangles are computed. And the reason why I'm showing you this is to push the limit of this wireless communication and networking in comparison with the computation-based technology. And as you can see, if you want to run this quality of the service with your phone, you have to spend like 150 watt, which is simply not possible. However, if you want to get the same quality service with the edge computing, which is doing this all computation and delivered only the captured image with this 30 frames per second speed, you can compute the new number, like including the encoding time and the transmission time to meet the 30 frames per second. And you're going to run this in the edge, so you don't count that the power consumption. You only count the device power consumption of utilizing this the millimeter wave or the higher frequency communication chipset. That is only taking like 2.5 watt. So comparing to 150 watt, this is a huge benefit given to the user. And if you want to make this quality even better, like to humanize, there must be a quality which is actually giving you almost no difference with this reality and the render video. And some people calculated humanized resolution, and I was able to scale up this number to match with this human eye. In the case of rendering, so you have to make this like a cubic based scale, right? Because there's a 3-dimensional rendering. So this is going to take about 32 kilowatt. But if you do the same with this mobile device, leveraging this 6G technology, maybe you have to put a lot of infrastructure. You can do the same with 5 watt. Can you compare these numbers? So my rough calculation might be a bit wrong, but I believe the calculation is not that wrong. So based on this number, we can insist that the 6G technology, when it is prepared well to provide some guaranteedness, it will do a huge job. It will really change the world. So one example of such services already implemented with the Microsoft Xbox Game Pass, and this game is rendered somewhere in the edge or some cloud, and you will see this demo that when you click, then this is about delivering your control and computing there with the rendering engine. You get the graphics delivered as a response time, and you see that the response time is already quite fast, but it doesn't tell you that you can get this response time persistently over time, and you cannot get this response time when you move, right? So there must be a guarantee provided anywhere, anytime with 6G, maybe in a confined area, right? For example, Singapore, because that's a small city center, you can provide this guarantee service, but for example, America, you cannot always get this service. You cannot expect this service. But anyway, by providing such futuristic experience to the user, at least for those advanced areas like Gangnam area in Seoul, it will make some impact. So to meet the time, I will quickly cover the remaining slides. To guarantee this response time over 6G, I can provide you one reference model. So if you can develop the 6G performance guarantee with this model, I believe it will fit for any kind of service. So I want to guarantee the response time over this round trip networking, and there must be a pre-processing time, which is including the encoding and the uplink time and the computing time in the edge, and the downlink time and the post-processing time, which might be a rendering time in the mobile device. And summing all these components, you should be able to cap it with this time of budget of the response. And one thing interesting is the pre-processing is going to help really much about reducing this uplink or the downlink. Because if you encode more or the encode brilliantly the data volume will reduce substantially. So you can trade this pre-processing and the networking time. So guaranteeing the networking latency might be the first job to do, maybe with the technology like network slicing, but that's not all in this 6G application perspective. So what you need to do is guaranteeing the total latency from networking and computing, because they have a huge trade-off relationship. And someone might say this is what exactly the semantic communication is doing. So they try to minimize the data volume by trying to deliver the meaning of the data. And if you can do that, then you can just save a lot of computing the networking time through that computation. And by doing so, we have some rooms to adjust these terms to meet this budget in a resource efficient way. Okay, so the networking latency guarantee, I actually spent a lot of my years to reduce the networking latency, which is the first bit latency plus the transmission time. So you have to remove all the queuing in the networking through designing this network to have zero queuing or the priority queuing. And you have to also provide the low latency transport protocol to keep this networking always having nearly zero queue, even when I'm moving. And then you have to think about this transmission time guaranteed. So the providing this bandwidth always in the same level is going to be the next key thing to achieve. And for that, maybe you can do this. You can create this like a channel prediction for each of the user, and the radio resource management control in the LIC can do just a resource allocation in the PLB level with the amount that application object wants at the moment. So this vision may be achieved with putting this reinforcement learning based knapsack problem solving technique running in the RU level, and you will be able to pack these application objects within their deadline efficiently with the given number of LBs. Of course, you have to implement the admission control schemes to reject those application objects, which is beyond our capability. And one thing to share with this slide, the concept is that because the efficiency of the resource, the block is going to be all different for each of the user, you have to compute this really hard in the LIC level. So the computing you need to do this is way beyond that what we have currently in the control plane. So control plane is very rough and it is intervaled and it's not adapting really fast to each of the application object. So I think to implement this 6G vision, you probably need to combine this data plane and the control plane together like seamlessly and implement this high-speed resource allocation scheme there to make the guarantee. And then you should be able to trade this computing and networking very well, maybe through sharing the database between the sender and the receiver. So you can just send only the conditional entropy like information. And how to achieve this encoding is a big open question. And my students in my lab are designing some brilliant encoding techniques so that the meaning of the data is purely extracted from the data, the original data, and compressing the size of the data about 100 times lower than the JPEG or the 50 times of the PNG image, given the task of neural network operations. So finally, this is concept video provided by Microsoft when they promoting their HoloLens device. And this video is fascinating because you are seeing all the visionary applications in one video clip. But how to achieve this has been remaining as a big open question in the 6G, but I really don't believe achieving the 6G KPI will automatically do this. And there must be a complete restructuring in the 6G to provide this application level API, which is giving them the comfort to develop their new services with the confidence that my application will run automatically over this API only by paying enough money. Okay, that's it for my presentation. Thank you.
Thank you, Professor Lee. So thank you for sharing the view on the hyperconnectivity for the 6G. So we are a little bit running out of time. So if you have a question, let's have some discussion in the break time.
Sure.
Right, thank you. Let's give him a big hand again. Right, let's move on to the next speaker, the Professor Zhong Lin Wu from National Taiwan University, Taiwan. So the title is Introduction of the 6G Research Program in Taiwan. So are you?
Hello.
Hello.
Everyone, do you hear me?
Yeah, I can hear you. So please
Okay,
go
great.
ahead when you're ready.
Yeah, it's my honor to be invited to give a talk here. Okay, let me show you my slide. So do you see my slide?
Yes. Could you make a full screen? Yeah, perfect.
So do you well see my slide?
Yeah,
It's okay?
Yeah, it's clearly.
Okay, let me start my talk. Thank you for your invitations. My name is Zhong Lin Wu. I'm from National Taiwan University. I'm also in charge now the program office for the key technology research on next generation communication system, which is sponsored by our Ministry of Science and Technology. We call the MOST. And in this program office, we have several co-chairs who are Professor Hongyu Wei, Professor Peter Hong, and Professor Guzhang Yang. And Guangxun is our researcher in this program office. And this is the outline of my talk. And I hope show you our 6G vision and the requirement first. And then I will give you a brief research program now is undergoing in Taiwan. And then I will narrow down to the most sponsored 6G program now undergoing in Taiwan. Okay, this slide show you the trend for the mobile traffic forecast. So you can see that the data traffic will grow very fast in next few years. I can say that it almost exponential growing. So up to the 2030, you can see that the data transfer will up to the 17 exabytes. So that's a huge amount of data. So that's why we need a new generation of wireless communication systems. In 5G, we have already deployed in many regions and many countries, and which has used very good applications such as the XR and ultra high density videos, and also the Internet of Things and the cloud gaming, etc. Especially the IoT is one of the highlight of the 5G systems. So we not only connect between peoples, we also connect to the machine and the machine to machine. And in 6G, that a lot of discussion now is undergoing, and which includes the holograms and digital twins and tactile internets and NTNs, non-terrestrial networks, etc. And we can know that in 6G, we not only connecting machine to machine, we have to very smooth and efficient interaction between the people and the machine to machine. So we can expect that we need a lot of new technology and a new development of the communications network. So I will show you more about our ideas. So this slide will show you the very interesting statistics. It shows you that the total production value of global communication equipments. And you can see that in past few years that the global communication equipment industry had reached about 600 billion to 700 billion US dollars. So and Taiwan's plays part of the roles that's in 2018 that we probably that's have 18% of the global value. And we expect that in 2022, that Taiwan's will covers 24% of the global's production value for the communications related equipment industries. So it implies that Taiwan plays quite important roles for the international communication community. So we have to share and contribute more our capability and our ideas to the global society. So I think a lot of speakers and we all know in recent few years that a lot of parties and organizations, companies propose a lot of 6G visions. And I think most of them are very, very interesting, and several consensus has been achieved so far. So let me summarize of them to you first. I think in the futures, that connection through the virtual world will become the very, very important trends, especially after the pandemic. That in the past it is nice to have a connection to the internet. But now and in the future, I think we have to and we need connection through the virtual world. And we know that metaverse will become a very important trend in the near future. So I think connection through the virtual world will be quite important. And to enable these kind of scenarios that I think mobiles, XR and holograms technology and a digital twin, something like this, several applications will be used. And based on these scenarios, I think several technologies such as high bandwidth and ultra high speed communication, and also low latency communication and high reliability, high security communication should be provided. And the second one is that in the future, I think 6G communication will be very efficient and smart. So we can expect that the AI assist or AI embedded communication network will be there. Okay, so a lot of AI technology and will be co-developed with our communication system in the futures. So based on this kind of AI embedded communication network, a lot of vertical applications such as smart city, smart transportation, smart manufacturing, agriculturing, such a diverse application will be developed. We all know that in 5G, such a smart something has already been there, but it's not much mature. So in 6G, I think this part will continue developing. And the third vision for us is that the ubiquitous connections, okay? In the futures, we need connected from the space, air, and ground to the sea, okay? Everywhere can be seamlessly connected. And because we not only have the activity on the land, we now had a lot of activity on the space, on the air, and also on the sea. So the seamless connections through the integrated network is become critical. So let me show you our idea that if we want to enable such visions, we need three very important technology. The first one is the extremely high-speed technology. Okay, so that speed can reach about 100 gigabit per second, even up to the 1 terabit per second. So a lot of people say that sub-terahertz or terahertz technology may be one of the options. It's true that because in that frequency band, we have a lot of bandwidth and can transmit more data there. And the second one is the intelligent and the diverse communication technology, in which that softwareization and the virtualization and the AI embedded computing on the very many low-cost white box equipment will become the trend. Okay, so in the past, we have a lot of black box core network, black box RAN systems. But now in the futures, I think a lot of white box equipment there and a very low cost and very flexible. In that environment, that a lot of AI technology can be embedded easily and to optimize and accelerate our communication network. And third one is the extremely coverage technology, which include the HAPS, the UAV, or the so-called LEO satellite. Okay, I think LEO satellite now is one of very popular technology that has already happens to connect people between the space and the ground. So we have the need to have the three-dimensional communication network. So I think these three parts will is quite critical to provide visions of 6G. So in next few slides, I will elaborate more about these three parts. So first, I will show you a big picture about our national program for beyond 5G and 6G in Taiwan. The program has two tracks. The first track is the program for the beyond 5G LEO satellite and the next generation communication system key technology. And this program aims to developing some LEO satellites, and that will be launched in next few years to the space. And inside the LEO satellite, some communication payload will be developed and also connected to the ground station. So it is a real test and a real launch of our satellites. So in this program, there's a sub-program which dedicates on key technology development of next generation communication system, which is sponsored by MOS, as I mentioned. And we are now on this program office. So this big programs is mainly handled by our national satellite program office. And they have a lot of experience to launch the satellite and developing a new satellite. And another important part is another track of the program is for the research program dedicated for the 6G industry development. This is a 5-year program, and the main purpose of this program is try to developing the prototype and the platform of pre-6G communication network. Okay, and this prototype is mainly developing from our research institutes, which we call the ITRIS, and sponsored by MOEA. And also we will establish several 6G advanced research centers in the University of Taiwan. And these research centers dedicate on 6G prototype development and try to link with our research institute and also link with our international partners. So we also have some sub-programs that dedicate on the 6G spectrums planning and rearrangement. This is handled by the NCC. We call the National Communication Commission. Okay, next I will narrow down to show you more detail about the most sponsored 6G programs. As I mentioned that there are two sub-programs that also handled by myself, and this one is a program for key technology, and this is a program for the advanced research center. So our program office will handle these two sub-programs. So our mission for the first track is try to developing the key technology and the core technology with the breakthrough and with innovations that can help our industry. And also we try to develop some essential IP or some very important technology that help our industry to go into this new generation of the communication systems. And in addition, we try to contribute and share our capability more to our international communities. So we try to use through this program to enhance our international visibility and impact. And also very important, the talent cultivation is one of the main purposes of this program. So we all know that new blood and the new generation in the communication area is very important, especially the high-level talents, especially with the PhD or master degrees. We try to cultivate such talents to contribute it to the global and the locally industries. or the academia. Another track of the 5-year programs, and which will build the several 6G research center in our university, will start very soon in this June. Okay, and this program, as I mentioned, that we are developing the prototype of the pre-6G communication network, and that prototype will link with the E3's developing prototype. E3 has a very good experience in developing the 5G or beyond 5G systems. So now they will try to step in the 6G. And through this research center, we can link together and also reach out to link to the international partners and also local industries and also the public sectors. So this program will start very soon. And the 4-year program has already kicked off 1 year ago. Okay. So in next few slides, I will show you more detail about our some core technology is undergoing in Taiwan. As I mentioned, there are 3 main parts. The first one is the extremely high-speed technologies. So we have the team developing the sub-terahertz and terahertz transceivers, and also dedicated on RIS development, and also the RIS-added MIMO systems. And let me show you more detail about each one. And for the transceiver, we are developing the 240 gigahertz transceivers. And this is a block diagram. You can see from the baseband processors to analog to digital converters. And this is our front end for the 440 gigahertz. So they will based on the CMOS TSMC technology node to developing such transceivers and to reach about 80 gigabit per second throughput. So it's very challenging, but I think this program try to provide the resource for our teams to developing such systems. And then we all know that the fusion of the sensing and communication is one of important aspect of in 6G. So we have a team from National Science University that they not only developing communication system, but also embedded the radar system, which has the environment aware capability. And they can sense the health condition and all the security condition of the environment. So that's a very interesting topics that combining the sensing and the communication. And this one will be developed in the sub-terahertz, okay? And in addition, we have a research on the RIS. I think RIS is now very hot topics in next generation communication systems. And we have already very strong team that from the National Zhongzhen University that have a very novel AI-assisted RIS. And also they have the EM environment sensing capability to change the channel property. And also they have the beamforming capability to compensate that channel loss, okay? And also we have a team from National Science University to have the RIS-added MIMO systems. So MIMO is very important, but if you can help by RIS, you can increase the spectral efficiency a lot. So we have a team dedicated on developing such very high spectral efficiency in 10 gigahertz band, and we want to reach 50 bit per second per hertz demonstrations. And next parts is for the second part is for the intelligent and diverse communications. And we focus on the Open RAN technology and also Open Core Network technology. I think these 2 parts are the main spirit of the communication network. So let me show you more detail about our Open RAN programs. And in these projects that we developing the key enabling software technology for Open RAN. And this project is handled by Taiwan Tech. And they includes the physical layer acceleration technology and also scheduling algorithm for multiple UEs. And also we developing some network service optimization in RIG platform, and also Open RAN virtualization in SMO, and also the high security and high performance design for information security. So we try to develop in such software modules and enhance their performance and to provide the ORAN in the futures. Okay. And about the core network, let me show you this good news that our team from the National Yangming Jiao Tong University have developed the world's first 5G core network, open source. We call the free 5GC. And this open source core network has been adopted by several projects and institutes internationally. Okay, so such as Apresa and OpenAce, they have already using this core network to combine with their Open RAN and establish there's a private network. And in this stage, our core network team try to develop more new technology that for the open source. And they include the TSN, we call time sensitive networkings, to be integrated with the beyond 5G and 6G. And also we try to develop some information security technology in this network, and also network slicing to enhance our service optimizations. And the final part is the 3D communications. And we have the team and from the National Yangming Jiao Tong University, and they developed the 3D integrated heterogeneous network for e-training coverage. And they developing some core algorithm, including that the beamforming management in the millimeter wave, and also the 3D network for computing, communication, and intelligent optimizations. And also we built the 3D UAV network self-deployment and optimization technologies, and also UAV tracking and detection algorithm. So we try to develop in a 3D heterogeneous network and the software and hardware verification platform, and also there's developing tools. And in addition, that we have a team dedicated on participation of the 3GPP standardization activities. Okay, I think 3GPP is one of very important activities that decides the trend and decide the future standards for the wireless communication systems. So we have a team dedicated on this part, and they focus on the satellite communications and the XR and the metaverse. So far is in release 18th. So this team and these two parts is important for Taiwan. I think also very important for the global communities. So here is our roadmap for these three main parts. And also each part we have a two stage. At the first stage, we try to reach 80 gigabit per second transmission and receiving transceivers, and also hopped up to the 100 gigabit per second up to the 2030. And also we try to develop in the intelligent diverse communication with Open RAN, Open Core Network, and then we will integrate them together. And also we try to develop the 3D network verification platform, and based on the UAV. And also we will develop in 3D network. And our roadmap try to catch the schedule of the IMT 2030 and also the 3GPP. So this is what I have, and thank you for your attention.
Thank you, Professor.
Welcome.
Yeah. So we have some question. I mean, we have some time to take some questions from audience or online. Is there anyone who have some question or comment? So if not, let's thank the speaker again.
Thank you. Thank you.
So yeah, thank you for all the three speakers. It was very nice talk, and thank you for sharing your journey toward the 6G. So this is the end of the session, the first session of this workshop, and we're gonna have a 15 minutes break, and let's resume 4 and 15 for as a session, the second session of this workshop. Okay, thank you.
Start the session too soon. So within 2 minutes. I think I start the introduction of the first speaker. So for the session 2, we'll have 2 speakers. So actually, for the session 1, we had a wonderful 3 talks, and we will have more 2 talks here. So the first speaker is Professor Tony Kwek from Singapore University of Technology and Design, SUTD. So we are really thankful for having Professor Tony here in person. So actually, and he will be talking about future communication R&D program in Singapore. So if you're ready, then please start.
Thank you, Session Chair, and thank you, friends from KICS and to set up the MOU. So the talk is actually a very high level of our journey this past year to set up this future comms program. So to kickstart, I just want to very quickly introduce my university, just 5 minutes. Our university is a startup, sort of a startup university. It's less than 12 years. It started off with a goal of bringing the East and West. It's a university. We have worked with MIT, Zhejiang University. It's an engineering university. Our goal is to do something different, bring design and technology together. But it's an engineering university. So we have a lot of partners. Our goal is to really bring design into engineering and into a multidisciplinary curriculum and design. So it's also related to future comms, which I will motivate later. So we have partners like MIT, Berkeley, and so on. Some of the research capabilities beyond FCP, there's like 3D manufacturing. So we have a professor who is very famous now doing printing food. So you actually have printing food for hospitals. So there's also future sustainability. The reason why we are selected, we actually, although we are a young university, actually we were recognized as a, in terms of new education. So our students, for example, needs to take machine learning and programming, regardless of whether you are architect students or computer science students. So it's compulsory. We treat machine learning like calculus. So that's something actually different in curriculum. Another reason why FCP is actually hosted at SUTD. This was a report done in 2017 by Clever Analytics based on, I think it's top 2% publications. It's normalized citation. So we are the only Asian university. Of course, we are small. Our number of faculty is about 100 plus. So if you normalize with citation, actually it's an advantage for a small university. So the rest are the top US school. So we are actually in the east side of Singapore, so our borders are open. We welcome visitors from Korea and all around the world to come. So this is where the east is. So the red part is SUTD. In the next 20 years, there'll be a lot of changes on the east. Because first of all, Terminal 5 is a new airport. It's actually, it was started building before the pandemic. Then it stopped. Now we are coming back again because Terminal 5 is the size of Terminal 1 plus 2 plus 3, very big. So there's a lot of design and challenging problem. One problem is with that massive airport, you will not find sufficient workers. So the use of robotics is important. But a lot of way that people deploy robots is you have a company, a cleaning robot, a security robot. All the platforms don't talk to each other. How do you actually have an integrated systems that is sustainable? Because one of the important factor is that all this infrastructure by 2030 needs to be be sustainable. So all the carbon issues will come in. So actually you have to design all this way beforehand. And this is what Singapore is good at. So in terms of design and planning. So there's so we welcome if you're interested in cities, aviation, healthcare. Then we have AI program. I'll just skip. I'll go to FCP. So this is a common question. Why we wanted to do this 5G or 6G program, because we are small. We don't have a presence in 4G or 3G. But because communications, or in fact 5G and beyond, is a foundation layer for services, right? And Singapore has a lot of services. Digital economy is a big thing. And if we don't have this foundation layer and don't have the capability and technology to do that, then we are actually vulnerable. So that's resilience is important. The second part, because of geopolitical situation around the globe, which means that if we don't have part in this technology, then if some of this key technology we are unable to use, then our certain sector will be in danger. So that's dangerous. So also build up this capability. So that's our rationale to build this future comms program. And in fact, is a lot of countries like Korea, even Taiwan and Japan are way ahead. So we need to strategize our money. It's not a lot of money. I'll just show later, and how to actually have an impact in this whole supply chain so that people want to work with us. So I'm appointed as the director for this program. It's funded by NRF and leading agencies, IMDA. It's a 4-year program from 2021 to 25. Your discussion on the next phase. I want to focus on translation, 5G translation and 5G evolution. There's a lot of things to do. If you talk about 6G or the vision, if we don't understand the translation and evolution well and the use cases, then a lot of vision, we may end up developing technologies that's not useful. Not useful in a sense that there's don't have business case, right? So, and also build out this capability. So it's a very practical approach that we are embarking. International partnership is very important so that we can leverage and have test bed. We are going to focus a lot of test bed. You see a lot of programs start with vision and, but I'm going to start with test bed. So I'm going to do a test bed, and all these test beds is related to all the different use cases you talk about in all the vision paper later. So first of all, one strategy is research. I mean, with $50 million US, it's actually not a lot. A lot of programs, like even Korea and other places, is like 100 over million. 6G flagship is about 300 million euro. So we're going to focus on the technologies that's relevant to us, economic capture and national resilience. Non-terrestrial is definitely important, because non-terrestrial related to satellite, there's two big sectors that influence. One is maritime. Singapore has a big part of maritime. How do we have this capability in this technology, how do you actually ensure our status in maritime sector? We will still be number one. Another sector is aviation. How will, with this non-terrestrial capability, how will all the aviation sector be different, and all the traffic flow is to come? Then in terms of mobile applications, there's a lot of services like MEC, all this related network orchestrations, all the low latency services, and security. Why I point out security? Because Singapore being a very neutral country, they have a tendency to attract countries wants to come to Singapore to test or to be certified, because they believe that it's a high integrity country, which we are. I mean, and so we believe that all these are important. So I'll briefly, because we just started the program, so I'll briefly talk about some of the research projects that has been awarded. And our second grant call is open. But actually what's important, our research project wants to work with key partners and of course with academia and companies. But another point I want to mention is, if you look at a lot of programs, 6G programs, they are really communications program. Like many countries, there's also other programs, satellite program or quantum program. They don't interact. We interact with each other. For example, subsequently, I'll share my test bed, where my test bed has a quantum link, or it's actually a fiber link connected to another program in NUS, where they look at quantum, and we want to look at even test cases and how these quantum communications can be linked to 6G. So we are very practical. We want to try and see, even satellite. So there's satellite program. So we have plans to how to bring this into place and so this will be able to attract companies to come because we are a new player. So establish international status is always important. As a new player, we need to make noise, right? Well, make noise, tell people we are into this, establish, for example, the MOU with KICS and subsequently with partnership with all the universities, so that actually you can build up our capability because we can't do everything and to learn all the good practices. Secondly, the 6G collaboration with partners like, for example, 6G flagship in Finland, 6G forum in Korea, there are also other partnerships. There are also partnerships with companies. Companies are interested in our test bed, in what we do. We do attract them, and there's ongoing projects and on. Participation in committee, as what the other programs has mentioned, is important to drive innovation because we want to be open. So, for example, participation in Open RAN, possibility of setting up an open testing integration center is important to be in part of the ecosystem so that people come. All these consortium or committees are important, right? So the next thing is also because all this research need to translate to actually ecosystem, right? Applications and sector. So we also have part of the money focusing on translation grant. So the faculty needs to work with companies. For example, we focus on future mobility, like related to maritime, land mobility. So these are called that the faculty needs to work with companies. For example, companies like even KICS and so on. Our next call will be on smart manufacturing, will be likely next year. Then I'll talk about test bed, a few of test bed, particularly on the open test bed I'm building or have built in SUTD. Right, so that these are some of the details. I will not go into details of the research trust. I'll just list some topics. You'll see satellite is a big thing. In fact, because we have a few big companies in Singapore that have satellite capability. Ground station satellite. ST Technologies is a big player. They have very strong in all these services. That's why having that partners is important to build. Then there's other areas. The edge computing and intelligence, because we have a lot of services company there in Singapore because AI services. Then this will actually dwell to it, and also cybersecurity, Open RAN, and so on. So these are research trusts. It's a bit small. Just give you a idea of some of the projects that will be just awarded recently. You see all machine learning related, edge computing related, hardware federated learning. This is MEC. Network orchestration related to ORAN, so multi-core processor. So these are some of the projects that we will run. So this will seed. So this will be some of the IP that is for sort of a B5G and beyond. Security is also another area. OEM, people are looking at OEM for much longer range as a 6G technology. Non-terrestrial network is also another area that is of importance to us. So these are some of the research projects. I'll be able to share more of the output next year when the PI has done some work. So more interestingly is our connectivity lab at SUTD. So we really focus on Open RAN. If you see even in the Taiwan's program, they look at open system, right? It allows us to actually adopt new technologies much faster, especially a new player like us. And some of this will be able to use for a government agency and so on. Very quickly, Open RAN has been very hot for private network. Rakuten has actually operating a private 5G network operating ORAN. If you track the trials now, particularly on UK, Europe, there's a lot of Open RAN trials currently in many countries, even in Southeast Asia. Countries like Malaysia, Indonesia, even Sri Lanka are looking at that for deployment of ORAN. Of course, Japan, particularly Docomo, is driving this. There's many trials in US and other places. So this is one key part. You see a lot of test bed. So this is where SUTD is. If you look at that, the red part is where our center is. So one goal is to put our AI center to get FCP. So this center will be ready in August. So because I'm in charge of my AI center in SUTD. So I require my AI faculty to work with my FCP. So they are co-located, right? Because communications need to look at services. And AI has a lot of services and demo that's interesting, right? So the AI folks will be there. So this is the plan. We put them together physically. If not, usually they're separate. So this is under renovation. I have my core network. So this is where my 5G core network, I'll explain to you, is really here. So I have indoor coverage across all the region. You have all these spaces. This space is a metaverse space that I'll design. I'll show you what my concept is. There's also robotic space and so on. Okay. So this is my Open RAN test bed. This is my first test bed. It's an end-to-end test bed that we work with vendor. There's two options in this approach. One option is you really follow the open platform. You build it from the scratch. But of course, the challenge is interoperability, right? It takes time. But because our first baseline is to look at the use cases. So it's an end-to-end. I have a 5G core network. It's a commercial grade. So it actually can support up to 10,000 UE. Of course, I don't need to have that first scratch. So I actually design in a way together with the vendor as like 2 cells. I have one BBU looking at outdoor, the other side indoor. I can reconfigure uplink and downlink. So this is an attractive part. So depending on the use case. I have 50 megahertz for this experiment. We have done some experiment. Also, the downlink is about 400 megahertz. Uplink is about 150 megahertz. Of course, this is release 15 only. The one good thing is working with the vendor is that there has a roadmap of release 16 additional feature that will be integrated into this. So it's a living test bed, which is what we want instead of just at 15. So then additional feature will come in. I will explain what additional feature we will see. So I just want to interest what. So when we design this, we have to design carefully. After you see all my space. So this is so there's other research problems related to this. This is a lot of interesting area. For example, the rig controller, the AI controller, the slicing, the security robustness, and subsequently looking at O-RAN connected to non-terrestrial network, because the ground station needs to connect to a base station. Then if you're able to implement your release 70 feature much earlier, then there's a lot of room to play. And eventually slicing, all this will come in. So there's the core and the RAN integration will come. So I want to look at the use case. So my use case is, as you follow the standard, even the 5G advances, you look at URLCC now is going beyond a higher rate. They're also looking at exploiting even the unlicensed band, right? The current URLCC in release doesn't use unlicensed band, but in a big factory, using unlicensed band like Wi-Fi, right, to have the competitive advantage, how do you actually use the unlicensed band? Sidelink is important because if everything goes to the gateway or the eNode B, there'll be a congestion. So how do you actually use the sidelink to actually enhance the design? So in order to do this, you need to have a test scenario. So just now, what I've shown you in that room, I have my core network. So I fiber all the way to 2 gateway. So you see here, there's 2 outdoor gateway. So this is also running on my N78. These 2 gateway are located diagonally across these 2 sites. So very interestingly, this is where SUTD is. I remember 7, 8 years ago when we moved over there, always think that it's a waste of space because a lot of buildings say you will actually fully build your offices. But then when I start to design this, then I feel it's a blessing because now I can create this as a drone arena because we are very close to the airport. It's no-fly zone. So now by end of May, I'll be a netting on top of the roof. Once it's netted, it's considered indoor. Then my drone, I have a 5G drone arena. So this is attractive because this is outdoor. Then the drone has a connection of GPS. I don't have camera. So now I'll be able to do testing all these URLCC. I can actually add additional infrastructure across like cameras, across this, you can actually introduce, for example, even UWB, MM-Wave. The ground part where you see the garden here will be under construction to build a robot arena on a flat. Then you can actually use a same place to look at platform interaction where the drone and the robot. So our vision to this is that if we can recreate Harry Potter's Quidditch, you know, the game, where in fact the person is at just now the level 3, put on a VR goggles, the drone will have a camera. Then you have multiple drones flying, these are data points. Then when you send back to the user, you just render and augment some picture on it. You can create different environment, very Star Wars and so on. The whole goal is to let people feel this real time and all this. But this could be a new industry, which is a gaming industry. Then with Singapore as a small space, then you can actually create different kind of, like F1 took a lot of space. But then can we create new gaming industry with 5G that have a confined space? So this is what we actually want to pitch this. So this is something we are testing with a vendor to look at this. So this is one case. Of course, there's a lot of challenges. Release 15, for example, that you meet this delay, that means there's a lot of things you need to do at the processing because the physical layer is 15. How do you actually ensure the delay? So there's a lot of innovation that you have to work on. Then there's other research to look at. I will not elaborate on this. But I want to go to another concept. What I want to show you is that there's a lot of vision concept. But to us, we are very practical. So I want to say, let's build something that can show this. And it's Internet of Sense. So it's actually very interesting idea. I mean, Ericsson showed about all these sensors. So there's a use of RF sensing, reconfigure intelligent surface and sensing control. So we're wondering, okay, so can we show something which is very close to the heart where people already understand? Is education, students. Because the 2 classroom has this private 5G coverage. So I have a classroom that have this, so it's connected to the core. So what we want to show is that instead of trying to do this, why not use students? And because with the pandemic, the Zoom experience is not so well. So with the technology of the 5G and beyond, can you improve this experience using our new sensors? Because let's say in a room, you teach your students finish already. Do we actually need to go to the lab? No. If they put on AR goggles, they can do hands-on experience right where they are. How to serve 20 or 40 students in a classroom? It's not so trivial, right? How to actually design this experience? How to use all the new technologies or robot? That can be done once you have this. Then you can slowly add technologies on it. This is what we believe. Then they can feel really, what is this? And the beauty is the data belongs to us. It doesn't go out because it's a private network. So we will have all the data for privacy issue. Of course, there's a lot of AI you can actually look at. So this is something we want to at least showcase, very practical. So of course, from a research point of view, there's a lot of challenges, right? I'm just showing we can build this and can improve on that so that we can work with our partners and collaborators. Metaverse, right? There's a lot of cute metaverse. We look at what Microsoft has done, but as a program, can we build this? Since we have a private network, so this is, okay, I'll skip this. Just now I have a classroom, right? With a classroom now, I want to create this. I want to show that actually connectivity is important. Now I have a private 5G network which I can connect. But then metaverse, what is actually different is multiplayer. First of all, I need to solve the location problem. Now, because we don't have a joint radar communication, but I can use MM-Wave radar. I can actually deploy MM-Wave radar. So this will give me centimeter location, but you need to feed back the information. So the goggles, whether it's AR, VR, first of all, you cannot compute on the glass because first of all, it's too hot. So essentially, you need to build the system instead. You have the edge together with the cloud. So what kind of information process at the edge? Just like the talk earlier, right? You have to be very intelligent. Not everything has a process. Now you have to build a system. What are the applications that you can do this? How do you actually design with multiple players? So this is the part that we are designing with some vendor to try. Then we slowly augment and increase the capability of this, right? All the new sensors. So then this is our goal. Then you can test the different protocol, because the vendor is also opening up SDK for us. So this is, and we have the edge, then we have the core. So actually, this is the end-to-end that we actually can manipulate the whole system. So definitely there's a lot of challenges, but clear thing metaverse will need 6G. But of course, I cannot wait until 2030, but we can do something right at the start. Maybe metaverse phase 1, phase 2, phase 3. So this is our what we want, and really experience the latency. So one question I really want to understand is, a lot of people say millimeter wave or can solve this problem, but in fact, how much can it do in this environment? I mean, just now the environment, the latency, compared to currently my sub-6, right? What are the scenario, what are the application? This has to be really set up and to see. And we have the wave band. So that's another thing that I want to add on this with wave. Then we can bring all these interesting companies in, because we also have companies look at blockchain, IoT, HCI. That's why the AI folks are there. A lot of AI folks on HCI. So once you create the environment, it's like you have an electric vehicle platform. We have a platform. Once people think, oh, I can add this capability on it, your cars become more and more powerful. That's our idea. We can't do it while I start, but we can build a platform so that they attract people to come. So that's our strategy, right? Have nothing, then attract people to add. Then at the end, once it's built, we have the know-how, because it's a system integration problem. So that's our strategy, how we do as a small country. Partnership is important because we are small. We have to be open, connected. So the promotion partnership, first of all, we always have to promote Singapore as an attractive technology hub. Right, way ahead of other countries, Southeast Asia, or even the world, to attract the top people to Singapore, companies and partnership. And we say that here, it's not just communications. Now we have quantum, we have AI service. All this can come together. And what is the new value you can create for a company? There's a lot of open experiment, not just my test bed. There's also Island, Sentosa. There's also other test bed that's around. Of course, that one is on a public network. So, but there's a lot of avenue to do that. Industry adoption, so we have partnership with companies, Singapore company, overseas company. They want to invest, have a presence, standardization. We will not go into standardization straight without IP first. So now we are looking at international partnership. There's more international partnership on the way, so that we can share, so can to build, to be part of the ecosystem. So there is this is the list. This is not all complete. There are more logos coming in. All these partners have a different stake in this, whether it's test bed or program, and we hope maybe some Korean companies will be there soon. Yeah, and of course there are across other universities and agencies. So this is my program, and I have a deputy director, and hopefully there's a delegation that can visit KICS and Korea in June, so that to expand the collaboration. And in summary, from our perspective from Singapore, is that connectivity and communication is a backbone, right? We have to be a smart nation, and digital economy is very important for us, right? So we feel that without this future comms, where 5G and beyond, what we talk about all the AI service, autonomous vehicle, electric vehicle, will not be able to be impossible. And to do that, we have to invest, and we believe that for this to be successful, we need to establish a consortium of strategic international partner university industry. So that's our approach to this future comms. Yeah, and that's my talk. And this building is donated by Jackie Chan. So our university is actually 400 years old, because this is actually quite old. Okay, thank you.
Okay, thank you very much, Professor Tony. And I think we can take time for the questions. So already the audience left a message on the YouTube chatting.
Oh,
So,
really?
okay, so I think we can take one question and then move on to the next speaker. So I will read the question, one question, then what is the significance of integration of Open RAN and core network? So what is the significance of integration?
Significance of integration, I guess, is because in the future, what happens is that you have services with different requirements, right? Whether it's a delay. At the end, it's not just the RAN, it's the end-to-end services. So having the capability of combining this core and RAN, you give you, I guess, more flexibility lah, because a lot of times at the higher layer, when you try to use AI or design, you maybe have to do something not so predictive, very low real time, but some applications need to do that. So I guess the whole goal of this is actually giving you more flexibility for applications, because our use case will be very complicated by 2030. Right. Yeah.
Okay. Thank you very much for the answer, and let's give a big hand to Professor Tony again.
Thank you. Thank you.
Okay, thank you. So we'll move on to the next speaker. Then the last speaker actually for the workshop, and the next speaker is Dr. Wen Tong from Hawaii, and he'll be talking about 6G defining a new decade. Actually, we have the presentation video, so if you're ready, then please start the video. And if you have any questions, please send the question through email. Okay, thank you.
6G will integrate sensing with communication in a single system. Radio waves can be exploited to see the physical world beyond eyes. Such capability offers autonomous driving vehicles ultra-high resolution and accuracy in all weather conditions. What's more, high-precision localization and gesture recognition will truly free our hands and make art creation anywhere, anytime. 6G will boast its native AI capability. Deep Edge architecture enables massive machine learning in a distributed and collaborated manner. Robots can thus harmoniously work and play with humans. 6G, the next horizon.
Hello everyone. I'm very pleased to have the opportunity to share our views on 6G. What are the 6G technologies and its impact to the future of wireless? Thank you for the invitation. The title of my talk is 6G is defining a new decade. Today, 6G is becoming a research hotspot for the wireless community. However, 6G is not just a simple upgrade for 5G. 6G is a foundational platform to shape every aspect of our life and work in the new decade. In this regard, 6G will be defined by 6 basic pillars. The first is a native AI. The 6G network will natively integrate communication, computing, and sensing capability. A distributed machine learning architecture will be the key to deliver AI service and application to anywhere at any time. Furthermore, 6G will revolutionize AI. The second is the network sensing. 6G communication system will integrate wireless sensing capability to explore the physical world through the radio propagation. It can provide high-resolution sensing, localization, and imaging and environment reconstruction capability to improve the communication performance and to support broad range of network service and scenarios, especially the AI. The third is extreme connectivity. 6G will provide universal high-performance wireless connections and ultimate experience with speed comparable to optical fibers. The fourth is integrated terrestrial and non-terrestrial networks. The fifth is native trustworthiness. And the sixth is sustainability and humanity good. 5G is defined with 3 basic capabilities: eMBB, URLC, and MMTC. Around this capability, a new network architecture and the radio interface were at that time defined with the cutting-edge technologies and performance. In addition to the further innovation around these three capabilities, for 5G, 6G will integrate the intelligence and sensing as a new capability. In this way, 6G is not only a platform for connectivity between the physical world and the cyber world, 6G is also a platform for computing, a platform for sensing, a platform for automation of the entire society. To make the connectivity fully intelligent and to deliver the intelligent service and application as well. The pyramid on this chart represents the vision and the definition of 6G. To the technical community, the representative key performance indicators for 6G are highlighted in this chart. The peak speed, user data rate, latency, and sensing resolution, and the energy efficiency targets are very challenging. These targets represent the wireless technology supremacy, meaning with all the spectrum up to the terahertz available and all the network infrastructure asset available, that is the base station grid, and what is the ultimate wireless capacity we can achieve. To accomplish these targets, we need to invent new enabling wireless technologies. For the academic community, this is indeed the technology challenge for the next decades. I will talk about 6 pillars for 6G technology one by one. The first is native AI. In this concept, 6G is not just a bit pipe to connect the machine learning, such as the learning and interference. The simple scalability approach can support some limited AI application, but not all the applications. The native AI communication aims to reach the level of a human brain, like learning and communication. Here, we design a revolutionary framework based on the Kahneman System 1 and System 2 theory. The key idea is that the capability of System 1 for each individual party of the communication can be modeled by deep learning. Such a model can be stored and shared with all the communication parties involved. It is in the cyber world before the communication. The real-time communication is only performed at the System 2 level. To elaborate further, the new machine learning-based communication paradigm consists of 3 parts. The first part is the inner channel communication, and the second part is the local communication between the System 1 model and the other words, the interdigital twins communication. The third part is the System 2 communication as at the so-called semantic level, which is in fact the semantic outer channel communication. The model has several new properties. It is low throughput, low latency, because the deep learning neural network contains a huge amount of memory after training. The memory capability and the long-term information and the other party long-term information to explore the context of a memory, we can effectively remove the redundancy of the communication, in which the entropy-based method cannot do. One of the most potential breakthrough of machine learning based communication is that the robust nature against the channel outage. This is because fundamentally with this model, System 1 is always on in the cyber world, while the system 2 can be on and off. When a mobility user is out of a coverage area, the perceived communication can be still carried on. The interaction among the system 1 are not interrupted, even though we lost the communication channel. If we have success in this deep learning based communication model, it will be a real breakthrough for 6G. Regarding to the 6G network architecture, one of the re-architected work of efficient support of deep learning rather than the simple over-the-top bit pipe for data rate scalability. In this chart, we talk about the distributed collaborative learning. We divide a large number computing tasks into many smaller computing tasks and leverage the communication network to fulfill this goal. We can flexibly distribute the AI function into device, the neural edge, and the neural center with so-called the federated learning. The merit of federated learning are two. The first is to keep the data privacy at the local, and the deep learning model is shared, not the training data set. The second is to drastically reduce the carbon emission generated by the learning process. The second architectural work is to support the low latency inferencing with distributed computing. It is always desirable to compute a small model at a device or neural edge to achieve low latency with less computing effort. However, in most cases, we have to make a trade-off for computing a huge model to achieve a good inferring performance. The inferencing computing with a small model and a medium model and large model is not a trivial task. The partition of the model is also associated with model training and model creation. In this chart, we have an interesting example for the early termination. The decision is examined at the full connected layer of the convolutional neural networks. If the confidence of each termination is not enough, then we need perform inferencing computing at the next level, the higher level. In this case, the previous level of computing result is not wasted, and we can use the weighted sum of the loss function to assist the next level decision. When introducing AI as a major service and application, we need to study the AI, especially the deep learning computation impact on the RAN capability and the high requirement in terms of big data required for the training AI model. As we mentioned before in the previous charts, the distributed learning and the distributed inferencing will need almost all RAN KPI to support QoS of an AI service. In addition to the radio resources, that is the bandwidth and the capacity, and the computing resources that is the AI model and the model density. The AI service KPI will drive the new connectivity requirement. Here, the AI service KPI as a service, are the service accuracy, service coverage, service response, and service energy efficiency and service quality. This will in turn to further drive the radio KPI, such as reliability, link budget, data rate, energy efficiency, and area of traffic. I would like to bring the attention on the study and the specification of uplink capacity requirement of AI training, which will be the bottleneck for 6G. Since from 3G, 4G, and 5G, our RAN design is downlink centric. with all the capacity allocated on the downlink almost, which may not be the case for 6G AI. The second pillar for 6G is integrated sensing and communication. Sensing by using wireless network is a game changer for 6G. We can natively integrate the sensing signal into a radio transmission wave for every 6G base station, every 6G devices. The radio transmission at the wider bandwidth and smaller wavelengths can provide much higher resolution of the real-time environment of the entire network. Even so, at the device side, we can use the terahertz technology to scan and receive the material and the detection imaging for many new applications. Therefore, 6G is a network of sensors. It is a crowd-sensing and federated sensing for billions of devices. Furthermore, we can use device-assisted networking and network-assisted device sensing to overcome the obstacles such as line-of-sight sensing, as shown in our in the right-hand side of the chart. The collaborative sensing and communication will allow the 6G network to see almost everywhere in the environment. The device can send the sensing information to the network so that the network and the synthesis of the sensing result can even for the non-line-of-sight cases. Of course, the additional sensing information will be able to utilize to assist the enhancement of communication performance. It is very effective in the case of a millimeter wave communication for the beam processing and the management, with more sensing assisted site information. This can reduce even to eliminate the beam searching, scanning overhead, and reduce the power consumption and extend the battery life at the device. Here, in this chart, we have two examples. The left-hand side chart, the UE is in the blocking shadow and cannot communicate with the base station. In this case, UE can trigger the site information communication to set up the data transmission where other devices like a D2D link or, for example, a pad as a reconfigurable intelligent surface. On the right-hand side of the chart, the sensing of people and a car can assist the autonomous driving to avoid the blind spot of the autonomous car and the blind spot for the people as well. For 6G, in addition to transmission the bit, we can receive and detect the radio wave with advanced signal processing techniques. We can detect the object signal parameter values such as location, velocity, moving trajectory. We can also reconstruct the object imaging in the real-time environment and the learning and to build into these into AI service. Furthermore, we can analyze the spectrogram of the object. Sensing will be a perfect complementary for 6G networks to deliver the AI service. Sensing is the source of massive data for machine learning, and it is automatically built into the single device, single base station, single frequency spectrum, and single air interface without the need of extra investment. This is very easy to understand that we can simply say the sensing data is at the natural gateway to AI. The third pillar for 6G is extreme connectivity. Here, for the new eMBB at the link level speed, the peak rate is 1 terabits per second. The network throughput is 100 times of 5G, and the new URLC, the air interface latency is 0.1 millisecond. The jitter is 0.01 millisecond. the network reliability is 99.99999%. The new MMTC, the uplink speed is 100 megabits, and the network capacity is 10 million links per square meter. For the new sensing, the indoor positioning accuracy will be 50 centimeter indoor and 1 centimeter indoor, 50 centimeter outdoor, and the image resolution can go as fine as 1 to 3 millimeter. Finally, for the AI capability, the learning is supported through the design of new EMBB, and the new sensing for the interface is for the inference is supported through the design of the new URLC and the new MMTC. The fourth pillar for 6G is integrated terrestrial and non-terrestrial network. Fully integration of those network elements will be considered for 6G architecture design. Our vision is that those elements will not form several separated and independent network. They shall be integrated as a single network at day one, which means the radio capability of the network elements are heterogeneous, but the network is unified in the air interface and the mobility arrangement. So we can leverage the global ecosystem and to achieve economic scale. There are several new and interesting capabilities enabled by the very low Earth orbit satellite constellation. First, on the left-hand side chart, we can use the cloud edge computing, can transmit the bandpipe satellite to bounce the signal directly to the car. The autonomous driving car can be controlled and operated by the edge cloud, where there is no cellular coverage. Another scenario is the smart grid. There is low latency service can be applied to the bandpipe satellite to broadcast the control command to all the stations of the smart grid at a minimal delay. Second, the VLEO satellite constellation can deliver the minimum latency service in the intercontinental scenario. That is faster than the dedicated fiber, because the speed of optical fiber is about 70% of a free space light speed. Finally, with the integrated terrestrial and non-terrestrial networks, the mobile device can use the dual connectivity mode to avoid coverage holes. The fifth pillar for 6G is trustworthiness. The first element is a security technology for wireless communication. Since the nature of a wireless channel is physically random for any point-to-point channel, the randomness is determined by the physical environment and cannot be cloned. In 1945, Shannon proved that one-time pad key scheme, once both data rate and the key update rate approach the Shannon capacity limit, such a communication system is a secure one. For 6G, we can realize by introducing this with a full duplex radio communication and leverage the random channel as a security key. The second element is the lattice-based construction for the post-quantum cryptography. Some of lattice-based construction appear to be resist to attack for both classical and quantum computers. The fourth enabling technology is the fast blockchain technology to ensure trustworthiness of the 6G network, which I will elaborate in the next chart. For the fixed network, the advanced security technique is the quantum entanglement for the encryption key. the research problem is how to generate the BB84 protocol to multi-user cases. Today, wireless network model is that the operator and subscriber are assured of a trustworthiness, which is built on the commercial contract, and the operator was the sole responsibility to maintain the integrity. As the network and the business becomes more complex, especially the geopolitics as a factor, in 6G we can consider the trustworthiness is not a third-party base, but rather than based on the massive distributed blockchain technology. In this case, we would like to put every operator, every activity, every protocol steps, every data transaction onto the blockchain so that every action is traceable, auditable, and yet anonymous and privacy are guaranteed. Here we have two technical challenges. One is to need the provision sufficient network throughput for the blockchain communication to meet the blockchain data, blockchain bandwidth and delay requirement. And the second is the lower latency, such as we can apply blockchain to the most of detail of the network operations. From the theoretical perspective, there is an information bottleneck in the deep learning neural networks. To be more specific, with the autoencoder structure, we can train the autoencoder to the extreme such that the output reaches information bottleneck. This means after training of the autoencoder, the huge amount of raw data is distilled to the minimum amount of data. And we can send the information bottleneck data to the other end so that the inverse of autoencoder, that again can recover the meaning of the intelligence and the massive raw massive raw data at the information source, but cannot recover the data of the raw information. This means keeping the privacy of the data at the origin of the source. Since the autoencoder processing is irreversible, computationally irreversible, it acts like a data funnel to retrieve the information with purpose. This is an innovation of data privacy, and we're going to pursue this research in 6G. The sixth pillar for 6G is the sustainability. Green and sustainable development are the core responsibility for the network and the terminal design in 6G. By introducing the green design concept and the native AI capability, 6G aims to improve the overall energy efficiency by 100 times across the network, while also ensuring optimal service performance and experience. At the core infrastructure of the digital economic, 6G will make a unique contribution to the sustainability development of the humankind. We need to establish the industry consensus on the methodology to evaluation the sustainability. This is the area for further study with an urgency. Two big drivers for energy efficiencies for 6G. The first is deep learning computing, and demand is double every 3 months. The open source software has a difficult to sustain. The second is the low efficiency of the millimeter wave amplifier, single digit efficiency of the power amplifier to overcome additional 20 dB or more propagation loss. These two are the long-term research problem to reach for the new solution, and we need a disruptive innovation. In summary, since these 2 years, the 6G research is gaining global momentum. Several national level programs has been announced across the world, and the planned investment into this program are very significant compared with the previous generation of wireless technologies. On the other hand, supporting technology of innovation for 6G is on the agenda for many of the government funding agencies. On the other hand, the geopolitics influence of 6G requires wireless ecosystem to overcome. So we can achieve a global scale and to realize the economic and societal impact for the 6G. With that, I conclude my talk. Thank you very much.
Okay, thank you very much. So actually, the audience on the YouTube left 3 questions, but since it was the recorded video, so I think you can ask the questions through email. And then thank you very much for all the participants in the offline and the more than 80 people in the YouTube. So thank you very much for all the speakers today. So I think it's time to close the session 2 and then the workshop now. Okay, thank you very much.